Hello there, this is ZoXDF, and today starts Advent of Code 2021. This is a bit not a hacking CTF, but just a pure programming one. But it's a lot of fun, and I'm going to try to do it on YouTube this year. So I haven't even looked at the challenge yet. I'm going to do them live, at least at the beginning. Um, so let's go ahead and dive in. I'm logged in here and go to challenge one. So they always start with some kind of story, and the idea is, so let's see, we're minding a business on a ship at sea when the alarm goes off. One of the elves tripped them through the sleigh keys into the ocean. We're in a submarine covered in Christmas lights, blah, blah, blah. So the antenna signal strength is displaying 0 to 50 stars. We need to collect all 50 of them by the 25th. We collect stars by solving puzzles. Each puzzle grants a star. The second puzzle unlocks when you complete the first, so there'll be 2 a day. This is how it is every year. So the submarine drops below the surface of the ocean. It automatically performs a sonar sweep of the nearby floor. On a small screen, the sonar sweep report, your puzzle input, appears. Each line is a measurement of the floor as it moves away, so it might look like this. So let's grab that and jump over to our terminal window and call this O1 puzzle. Oops, actually, let's see it. Vim 01 example. Okay. See, that we get, make sure we got that right. Starts with 199. Jump back to here, 199. Okay. This report scanning outbound, depths are blah, blah. The first order of business is to figure out how quickly the depth increases. So you know what you're dealing with. You never know. To do this, determine the number of times the depth measurement increases from the previous measurement. Okay, that seems easy enough. Let's give it a shot. So we'll do vim day01.hi. Obviously start with our shebang. User bin env python 3. We're going to import sys. Actually, we don't need that. Yeah, we'll import sys because we want to be able to give it a file name that we want it to work with. And now we can do with open sys.argv1 to get the file name. We're going to be, that'll pick the file name, and we're going to read as f. And now we can do lines equals f.read lines. And this is a place where it might be easier. We know we're going to want numbers, so we can map, I think this will work, int to .read lines. See if that will work. Python 3 day1.py, and our example is O1 example. Oops, and that didn't error out. That's good. Let's see. So what does our lines look like now? A map object. List lines. That's what I want. Sweet, do that. Although I wonder if I can. I think I can just iterate over that. Actually, let's leave it like that for a second. So what I want to be able to do here is loop over this and compare one to the previous one. So I've talked about this in a previous video, but I'm going to use zip. So let's see. I wonder if I can keep using lines or if I need to save it as a list. Let's try it for a second. So if I do lines, if I do zip lines, make it a list so you can see it. Nothing. Okay, I think the map object will only iterate once and then it's gone. So we're just going to save it as a list here right away, so that now we have an object we can work with multiple times. Oops, that's not lines. So if I do zip lines, what the zip object does is it will pair objects together. So in this case, because I'm doing the same thing, you just get each object twice. So what I really want to do is get just starting from 1 to the end there. And now I get pairs of the first, so I get the first one, the second and the third, etc. So now I can easily just do a loop over this. So I can do, the list was just a display, but now I can come in here and say, you can do x comma y, x1 comma x0 comma x1 for x0 comma x1 in, and now I can just do a test. What I'm trying to find the number of times it increased. So the number of times it increased would be when 1 is greater than x0, like that. And now I think I can just do that, and that's my answer. So print part 1. We'll make it a little bit nicer here. Grab this. Part 1 equals part 1. Don't need the minus I anymore. Part 1 equals 7. That looks good. Let's go back here. And now, so I need to grab my actual puzzle input. You know, one of the things they always do is they give you kind of a toy example with, you know, here's 10 readings. And then the real input to have to solve for is, you know, many. So we will save like as. There we go. And this will be O1 input stuff. There we go. And so we go back to our terminal. We get 1342 from here. And we got our gold star. We're on to part 2. Part 2. Considering every single measurement isn't as useful as you expected, there's too much noise in the data. Consider the sums of a 3-measurement sliding window. Again, considering the example above. Okay. Start by comparing the first and second 3-measurement windows. Their measurements are the sum. Let's see. The measurements in the first window marked A, their sum is 607. The measurement in the second window marked B is 618. Basically, we're doing kind of an average over 3 pieces here. So the first increased because 618. Okay, so let's see, we need to now look at this as sums. So let's see, how are we going to think about this? Not quite as simple as our zip from before. But we need to be able to get. We're going to need 4 items at any given time, right? Let's see. Let's go back here and run this again. So we have lines. And let's see if we do a zip. I don't know if this is going to be great, but we can do a zip of lines like that. Lines 2 and lines 3. Let's see what that looks like. Well, that's not what I was expecting. I expected to get more than that. I mean, I'm trying to think of an elegant way to do this, but the quick and dirty way to do this is going to be to just loop over. So I can do this. This is like bad Python practice. You're not supposed to do it this way, but for the sake of trying to solve it quickly here, because at the end of the day, this is a coding competition where you're supposed to be trying to rush. It comes out at midnight every day, so I'm always asleep, so I don't ever try to compete in that. But I can do I for I in range, len lines, and then I can say what I don't want. I need up to 3. I need 3 sliding windows, so I actually don't need the last 2. I can do -2. And then here I can do some lines I comma I plus 3 is less than some lines I plus 1 to I plus 4. Let's see, what does that give me? It does give me 5. So what I've done here is I've basically said I'm going to loop over the range from the length of So from 0 to the length of I, but I don't need the last 2 because I need a sliding window each time. Um, so what I can do here is, let's come back here for a second. If I do, just to show you how what it's doing, comma, and there, I think that'll work. I don't need the sum. So I do this. You can see what it's doing is, so it's creating these tuples, like this one, and then this one, and then this one, etc. And in each tuple, it's getting 3. So 190, well, lines up, we have it right here. So 199, 200, 208 is here. And then it's paired with 200, 208, 210, this one. The next one is you'll see is the same as this, and it's paired with the next 3. And so if I then come in here and add a sum around each of those lists, now I'm getting the 2 numbers I want to compare. And then if I want, then instead of printing that as a tuple, I'm just going to actually convert that to a actual comparison. So now it's going to return true or false. That's why I get the trues and falses. And Python is just nice enough that if I try to add together, if I try to treat trues and falses as numbers, they come out as 1 and 0. So I can just do that and get my result. So I can come up here and do part 2 equals. Let's give this a try. And this is, again, this is ugly. You're almost never in Python supposed to be doing for I in range, blah, blah, blah. I might come back at the end here and try to see if I can figure out a more elegant way to show. So let's see. Part 2. So if we run this now, let's do what the actual input. 1378. Let's see if that worked. And it did. Awesome. Let's see if I can clean this up a little bit and play a little bit more with making this look nice and not having to do a range len lines. So let's see. I can do a list of zip of lines 1 to the end and lines 2 to the end. What does that look like? That looks like what I was looking for. That I'm not quite sure what I did earlier and that didn't work, but I'm gonna try to work with this here. So what I can do here is I can actually save this as like zipped equals that, and then I can do another zip to pull this together, because now what I got here is I want to pair objects just like I did before. So this time I want to do list zip zipped and zipped 1 to the end. But let's see. And so this is tuples of tuples, but you can see this right here is 2 pairs, and this right here is 2 sets of 3, and this right here is 2 sets of 3. And I'm starting to get what I want here. So now I can make this into a list comprehension. So if I do x0, x1 for x0, x1 in, oops, yeah, and I don't want to do this, but I want to do a, let's do sum of x0, sum of x1, and I just put that in the tuple. So now I should have my 2 sums. Yeah, so here's the 607, 618, 618, 618, 618, 617, etc. So now I can, instead of making this a tuple, do my comparison. I got trues and falses, and I can do sum. Okay, so let's come up here and talk. Let's look at how we make this better. Get rid of that. And what we really want is part 2 equals. So we need to do 2 parts. First we need to do zipped equal, not with 3 P's. Zipped equals, and we'll do our list here like that. And now we can do our sum here like this. And that should be it. Let's see if that works. Let's get out of here. Where's my input? 3278. I believe that was the right answer. There's got to be some way to see the right answer. Turn to your Advent calendar. Down here at the bottom, 3278. So that's right. The other thing that's kind of neat here is what this really means is I can make this a single generic solution that solves both of these. So let's see. Def solve. And the secret here is that I want to take in kind of an unknown size of arrays. So I'm just going to take in lists like this, and then I can make my zipped equals list zip lists like that. And so when I pass the first one in, this isn't going to do nothing because it's passing in individual items. So it's just going to zip individual items together into, let's see, I can probably show you. It's probably easier to show than to tell. So if I do, so if I do the first one, I'm just going to do, what is my lines? So if I do list, zip, and in the first one, I'm going to pass in just lines like this. And it's going to return just the items. So it's fine. That'll be handled fine. But in the second one, I'm going to pass in 3 sets of items. So I'm going to pass in this lines 1 on and lines 2 on. And here it's going to return the triplets. But what's cool is because when I apply the sum, it's not going to care. Because when I sum, the tuple, let's see, sum 199 comma that, the answer is 199. So I can make this generic function here that takes any number of lists and zips them together. And then I can do my same thing I did before, which would be x0 sum of 0 less than sum x1 for x0, x1 in zip, zipped. So I'm doing 2 zips, just like I did there. And what I'm going to do is, so in the first case, it's going to grab these 2 right here, and then it's going to grab these 2, etc. And then the next case, it's going to grab these pairs. So I can now get back up here, return sum like that. So now, hopefully my spacing's not off. Okay, yeah. So now I can print part 1, and in this case, the answer is I'm going to do solve lines like that. I can print part 2, and I'll do solve lines, comma lines 1 onward, comma lines 2 onward. That closes the solve, closes the string, closes that, closes that. I'm sure I've made a typo in here, but let's see if it works. Let's see, yep, syntax mesh. Okay. I need a here. See if that works. Parentheses does not match. I did this too quickly, clearly. So my sums are good there. Or x in my zipped is there. So that goes there and that goes there. That looks better. Try one more time. Ooh, it didn't like it. So this is where it's good to jump into PDB. Let's see, what line number am I on? 18. Minus MPDB minus C break 18 minus CC, and we run to that point. Lists looks like what I want. If I do a next, the zip looks like what I want. Okay, so let's just start to build out our. Aha, okay. So let's see, what do I want here? Let's just do x1 comma like that. Zipped and zipped. Do interesting. That's not what I expected to see. Let's see. So we do a list zip of zipped comma zipped 1:. Oh, I see the error. I don't see the error in that line, but I see the error here. I am taking the last item of zipped, not one onward item of zip. I wonder if that's what I did earlier. That seems to be it. So that was a silly mistake, but let's see. So there you go. That's the much more. There's the much more Pythonic ways. And this, I thought this was particularly neat because you can apply. Now I have a generic solver that just solves both parts 1 and part 2. So thank you so much for sticking to the end. I will come back to you tomorrow with another one.